There we go.
Okay. The characteristics of the crust. The outer layer skin of the planet is composed of igneous, metamorphic, and sedimentary rock. The temperature of the crust doesn't refer specifically to the surface of the planet. It is in fact kilometers deep. Taken as a whole, you can have temperatures to 60 degrees Celsius in Antarctica to 400 degrees Celsius at the farthest depth of the Earth's crust. The crust contains the following: oxygen 47%, what's that word? Silicon 28%, aluminum 8%, iron 5%, what's that word? Calcium 4%, sodium 3%, potassium 3%, magnesium 2%, and titanium 0.5%. All others 1%. The crust is made of largely of igneous rocks, along with smaller amounts of metamorphic and sedimentary rock. The size of the crust: there is an oceanic crust and continental crust. The first one is about 4 to 7 miles, 6 to 11 kilometers thick. It mainly consists of heavy rocks like blastic. The lithosphere includes the crust and the uppermost mantle, which contains the hard and rigid outer layer of the Earth. The lithosphere is under by the atmosphere, the weaker, hotter, and deeper part of the upper mantle.
Okay. The characteristics of the mantle are the layer directly below the crust, which is delineated from the crust by the morphic discontinuity, where seismic waves increase in velocity. The division between the mantle and the crust is a chemical one. The rocks and constant minerals being higher in magnetism and lower in silicon and aluminum. The crystal rocks, the mantle comprises 84% of Earth's volume. The composition of the mantle is: the Earth's mantle is composed of rocks that have higher concentrations of mafic minerals containing iron and magnesium, and lower in concentrations of the phosphatic minerals, aluminum and silica, than the rocks of Earth's crust. The concentrations of the above elements therefore mean that the Earth's mantle is composed of a series of minerals that are predominantly calcium, iron, magnesium, aluminum, silicate. The temperature, size, and 5 facts of the mantle are: the Earth's mantle is thought to be composed mainly of oil-rich rock. It has different temperatures at different depths. The temperature is lowest immediately beneath the crust and increases with depth. The highest temperatures occur where the mantle material is in contact with the heat producing core. This steady increase of temperature with depth is known as the geothermal gradient. Rocks in the upper mantle are cool and brittle, while rocks in the lower mantle are hot and soft, but not molten. Rocks in the upper mantle are brittle enough to break under stress and produce earthquakes. However, rocks in the lower mantle are soft and flow with subjected to forces instead of breaking.
I'm doing the outer core. The outer core is a liquid layer about 2,260 kilometers thick, composed of iron nickel, which lays above the inner core. The temperature is 4,400 degrees Celsius to 6,100 degrees Celsius. Well, without the outer core, life would be very different. The ionosphere is a proportion of the upper mantle just below the lithosphere that is involved in the plate tectonic movements and isotonic, and that's it. I have to do the inner core.
Okay.
Okay. The inner core. Earth's core is thought to be composed mainly of an iron and nickel alloy. This composition is assumed based upon calculations of its density and upon the fact that many meteorites, which are thought to be portions of the entire of a planetary body, are iron nickel alloys. The core is Earth's source of internal heat because it contains radioactive minerals which release heat as they break down into more stable substances. The core is divided into two different zones. The outer core is a liquid because the temperatures are adequate to metal and the iron nickel alloy. However, the inner core is a solid, even, tough. Its temperatures is higher than the outer core. Here, tremendous pressure produced by the weight of the overlying rocks is strong enough to crowd the atoms tightly together and prevents the liquid state.
Huh?
How many minutes?
6 so far. It's almost 7. Oops. Hold on.
Kenzie.
Hold on, let me get on. There we go.
Okay, we're doing our density presentation now.
As you can see, this is already wet.
Just dropped that on my foot.
Shh. Sorry.
This is paper, and it doesn't float because it's wet, but hold on.
Here, take another
Okay.
piece.
See, this is paper, and it floats because it is less dense than the water.
And this is a wet cotton ball. And if you put it in, it floats.
In the middle.
See? It floats. Because it's wet. Now put the dry cotton ball in, Ashley. It floats.
It will eventually sink, but we also have a penny down in here that Chelsea dropped earlier.
And it's more dense. That's why it sinks. Sinks.
And that's it.
And density, if we didn't have density,
Oh, yeah.
the world wouldn't float.
What about the probe?
And the probe. Oh yeah.
Do you think it's right or not?
No,
No.
it's a bad idea because
We don't
It's
have that
just a
much money.
bad idea.
no, we don't have any money. It costs too much money.
Ain't got no money and it's just a bad idea overall.
With the economy nowadays.
It's
That's the
bad
end.
idea.
Bye.
It'd be pointless. Right, bye.
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 Do I push the red button again?
Yeah.